Hello, it's Friday, live from Maui. So today the subject is future electricity. And this is going to be based on a new concept, and the new concept is based on a new foundations for physics. Right down in the center of the proton is negative infinity, the lowest place in the universe. If you look up at the sky, it's a positive infinity up there, that black area above at night. And for an electron, that's like relative to a proton, just as Earth is relative to the sky. And in a way, the electron is a kind of flatland, stood on edge. So, of course, there's that famous book by Abbott about the flatland. But now in this one, an observer standing on the surface of the electron is looking up at a two-dimensional interaction with the proton. So there's only two space dimensions, and I'm going to be illustrating that for you in just a minute here. And I'm going to adjust the video here for a second. And let's see if I can talk and adjust things at the same time. Oh yes, and so what I'm going to do is turn the camera around so that you can look at the plan in text and graphics on a separate computer. So I'm going to turn it around abruptly now. Alright, it's a tiny tripod looking at the computer screen of nuclei, but what I want to bring up first is the text, which is showing some of this wide angle kind of a view of my plan for today, of what I'm going to be talking about. And you can see it's about future electricity every day, well, 3 days a week. Monday, Wednesday, Friday at 20 hours GMT. So in California, that's like 12 noon right now. November 8th, 2019. I just wanted to go over an overview of the philosophy of physics. In theoretical physics, there are many ways to describe a phenomenon, such as Maxwell's equations is one way, and I'm proposing an alternative to that, which is compatible with it. And I have confidence that my ideas are right when I ask myself the question, what if the world works the way I wish it would work? What would I wish for? And that's what I'm showing you today. I wish that mass equals an area of continuum liquid. That 1 kilogram can be converted to a relativistic type of phenomenon of 1.21 square meters of the liquid. That's because proton mass I'm setting equal to its neutron scattering cross-sectional area, 20.4 barns. And also I'm introducing a new kind of accounting for physics, 8 dimensions. Of course, you're all familiar with the moment of the x, y, z, and t, 4 dimensions. And actually, if you divide some of these things, you can, for gravity, get the momentum of free space, p. And there's the value written down for you. And this is a momentum that is mirrored in the center of the proton to produce 4 more dimensions, hx, hy, hz, and th, a time-like dimension that goes the other direction. I'm also introducing a unifying concept, a non-crossing law for proton-electron pairs. This unifies the concepts of the Lenz's law, the Pauli exclusion principle, and the up-down spin quantization. On that count, basically the external B field is making it look like it's up-down spin quantization, as long as there's a B field externally applied to the atom, then you can see that. If you take away the laboratory excitation, then it doesn't have to be only up or down. Now, also this non-crossing law, using the Pauli exclusion principle, explains radio. How one electron and one proton are paired, but those pairs bump into other pairs, like universes bumping into other universes. Now, using these concepts of non-crossing, I've defined the North Pole, I've redefined ferromagnetism, and now, as far as redefining ferromagnetism, I have an in-depth discussion, which I'm going to tell you about in about 2 seconds. It looked like the audio dropped out on that one. I better put my glasses on and figure out the audio there. But I'm going to later redefine force. Let's see, I got a button to push over here. But I had an audio problem there. I'm going to now push another button. And let's see if we can get... Yeah, I think audio is on. Good. So anyway, here's a paper that I wrote on redefining ferromagnetism. There it is, Ferromagnetism Redefined. And this was published in the Journal of Nuclear Physics in March of this year. So let's see if I can magnify this a bit here. Yeah, there it is. Magnetism from iron's nuclear structure. By me. Here's the abstract in a nice PDF document. Written July 2nd, 2018. Abstract. In this proposed theory, the nucleus of the element iron has a shape that causes ferromagnetism, and that also makes stability for iron. The protons in iron make loop shapes. The loops are coaxial. At the center of iron is a cube made out of protons and neutrons. And I go on to showing photographs of various models that I made, showing that the reasoning, the geometric reasoning and the logic is something I think you would agree with. So in the first figure I showed that if you just take random baryons, 26 protons, 31 neutron BBs, where the red ones are the protons and the white ones are neutrons, then if you just, on the left you see them randomly pushed together. You notice that one thing is that the red is touching red. Just at random, the protons will touch protons, and you really cannot avoid that. If somehow you could randomize this and you'd see, well, here we have protons always being isolated by neutrons, because there's so many neutrons that everything is surrounded. All protons are... No, that doesn't happen when you only have 26 protons. Now, that makes a profound realization that in the nucleus of a stable element, protons touch protons. And by inductive logic, you can make a line of protons form preferentially. And on the right side, you see iron exhibiting the lines of protons lining up into rings. So then this paper also goes on to show the cube that makes up iron. There's the protons in red and the neutrons in white, zinc, BBs for 3 layers, 27 of them. 8 of them are repelling each other. Protons repel each other, so they are at the 4 corners of the 8 corners of the cube. And the cube is covered with little pyramids, lithium-5. That's why lithium is rare. Iron is common. So now here's the assembly sequence as we start putting together lots of tiny pyramids of lithium-5 onto the cube. And on the left you see the result when you finish. On the bottom you see there's 6 little pyramids ready to armor the cube. Once it's armored, it's almost invulnerable to destruction through collisions. Other elements are not so lucky as iron, and they are vulnerable to, like uranium. Now here I am assembling this nucleus. All I have left is one more lithium-5 pyramid to go on the last face of the cube. And it's easy to see the cube on this. I'm going to zoom in a little bit closer there, if possible. And then it all nestles together as if a hydrodynamic flow of space were forcing the nucleons into a cluster. Now, the rationalization for having a cube at the center, well, the cube is only one possible thing which we could have there. For example, we could have had hexagonal close pack instead of a cube. We could have had a hexagonal close pack at the center of iron, and then we could have stacked them up, nestling together somehow. And then the problem is that how does it terminate? It terminates with a simple cubic surface on the exterior of the nucleus, making it highly vulnerable. You see, a cubic lattice like this has a large gap, making it vulnerable. It needs armor there. Now, the hexagonal close pack has small gaps. Like in iron, we see the exterior of iron is a hexagonal close pack because the center is a cube. If you have a hexagonal close pack in the center of a nucleus, it doesn't work out very well because the exterior will have these large cubic kind of gaps. I made the models. I worked it. I tried to get the lattice that way, and the decision has been made. I am 100% confident that the shape of the nucleus is based like on iron. The hexagonal surface on the cube is called face armored cubic lattice. So let's go back to some other talking about things here, and we'll see that what I was just about to say, since I've already talked about the rings inside of iron, is defining the cause of ferromagnetism. Now, that may disagree with things you read in the lay press, Wikipedia or something. They'll tell you it's the electrons that make iron so special, and the nucleus is swept under the rug. Well, now I've revealed in that paper, March 2019, Journal of Nuclear Physics. You can read it, the whole thing. It has the periodic table of nuclear structure in there also. And with that kind of thing, you can see iron in silhouette there. So going back to the overview, we'll see that I'm going to talk about force. I'm redefining force for you as follows, in complete detail. mass is affected by gravity, but mass does not cause gravity. That's in opposition to what other publishers would tell you. For example, if you look at the mathematical theory of special and general relativity by Ashok and Kati, he claims that even beyond the postulates, that gravitational mass is the cause of the gravitational field. He actually wrote that in his book here, and that's an authoritative statement, I think, according to standard science. However, I'm going to show you that mass is an area like a parachute in a liquid, and gravity is caused by the volume changes of space near protons and neutrons. Each proton and neutron has a volume that consumes the space around it every 5 nanoseconds by an amount equal to the volume of the baryon. Now here's the old science, and I'm going to replace Newton's gravitational constant and Coulomb's constant with a new function of r, the radius of the proton. There it is, F equals g, and Newton's equation. Big mass, little mass, divided by the radius squared between the two planets is the force, or whatever. And I'm going to replace g with what it says below here. Now, electric force, the Coulomb, is k, Coulomb constant, times q1, q2 over radius squared. I'm going to replace that for you also. Now, g is equal to the volume of the proton, v, divided by 2 pi tau m second. Tau is 5 nanoseconds, m is the proton mass, and the second comes from the experiment of a 1 second test. We drop a rock, falls 4.9 meters. We calculate tau from that based on the volume of the proton. That's because the momentum of free space is v over tau, a constant for every proton and neutron in the universe. So we can translate Newton's equation with two big masses into a volume causing the gravity and a mass being affected by the gravity. And then we can calculate the equal and opposite force of a small volume object causing gravity to attract a large mass object. All right, here we go. So now we see that I'm using a radius of the proton of 0.95 femtometers, and then that makes tau 5 nanoseconds. And the standard number here of the momentum of free space is 7 times 10 to the minus 37th cubic meters per second. That's how much every baryon consumes of the space around it. It consumes its own volume every 5 nanoseconds. All right, that accounts for all the space constantly shrinking in towards the Earth. And time is emitted in an equal amount radially from every baryon at the speed c. Now, once you go through the translations of this algebra, you'll see that using the volume of a proton equals 4/3 pi r cubed, you get these two equations for Coulomb force for electricity and the gravitational force, the big F. And notice that it's the radius squared for electric force sets the strength, and it's the radius cubed, the volume of the proton, that sets the strength of the force of gravity. And this is consistent with the other part of my theory, which says that the electron uses 2 dimensions to connect to the proton. I'm going to zoom in on this a little bit, I think, here. All right, so here's the iron nucleus. 2 rings of 12 and 12 protons. All right, and one on the right, you see there's one proton, the green, has been selected here, and it's connecting to one blue electron over there. through 2 black lines and 1 red line. So in other words, EX and EY are the 2 space dimensions going from the proton to the electron, and HT is a time-like dimension going the other direction from the electron to the proton. That's what causes torque in magnetic circuits and things, of bar magnets and things. And also, this is showing the connection to the force equation that I was mentioning earlier. Now here's another sketch showing the entire universe. Now the blackness is positive infinity of the sky at infinite distance. There's 1 proton at the center and 1 electron paired by 2 red lines and 1 yellow reverse line. That accounts for spin. For example, if we look closer at the electron there, number 5 there is going to the right, an arrow, and then above it there's an arrow going to the left. That's the counterclockwise spin. And then at the bottom you see there's another arrow going the other way. So that's the clockwise spin of the electron type of thing. So where my arrow's pointing, in other words, this arrow and that arrow is spinning clockwise for the electron, but also it's going counterclockwise from the other time-like, from this time-like yellow into the space dimension, the red. So you get both spins for the electron available for an observer. Now the observer, of course, would have to use a different atom. It's not in this picture. So any B field you put into this that starts sweeping across this as another membrane, a 2-dimensional contraspline, that will cause some kinds of interference or an effect on the spinning up-down quantization, so that you'd be able to observe either the up or the down as this picture is being swept by an external atom from your laboratory. All right, now I think I'll just go back to my text overview here. Force. That's right, I was talking about force. Therefore, the Coulomb constant, by using this type of a setup, is K equals the proton radius squared divided by the proton charge squared times 255 newtons. That's a whole lot simpler than what Mr. Coulomb taught us. Radius squared over charge squared, just for the proton. And when you bring one proton within one radius of the other, it exerts 255 newtons of force between the 2 protons. That's clear, just as long as you have this radius squared over radius squared. When the big R is equal to the little r, then this factor turns into 1. So as you approach a collision between 2 protons, they are exerting 255 newtons multiplied, if you have multiple n charges and on a large object and small n charges on another object, then this is the force of Coulomb force. And the gravitational force is the formula I'm highlighting here. Radius cubed over radius squared. They cancel out, so all you're left with is a meter in the numerator. And then in the denominator you have nanoseconds and seconds, so it's seconds squared in the denominator. Combining that with the distance in the numerator and the time squared in the denominator, that's an acceleration. Multiply by a mass and you get force. So now there are small n masses but big N volumes. So that's one force. There's an equal and opposite force when that volume is in the smaller object and it uses small n. But it's affecting the mass of a large number. There's the mass times n, the larger number of the Earth, 10 to the 51st power baryons. And so there's two equal and opposite forces. The Earth's volume causing gravity and the area of a satellite being affected by it, the mass. And the opposite force is the volume of the satellite causing gravity and affecting the Earth and all of its area of its mass, like so many parachutes being drawn up towards that. These two equal and opposite forces add up to zero. All right, so let's move along now. Except for, I wanted to emphasize something about relativity. As I said, G is equal to the volume of a proton divided by 5 nanoseconds per kilogram per second type of thing. Now, in relativity, they are still using G in there. If you look at Einstein's equation on page 108, if you go to the mathematical theory of special and general relativity by Ashok and Kati, you'll see on page 108 that the big G is being used by Einstein, and they don't ever explain why gravity has a certain strength. Okay, we're back to Mr. Kati. You see they have G in here, a whole lot of G going on. They even call it kappa sometimes, so you can't tell that Isaac Newton has determined the strength of gravity, and Einstein had no idea how matter caused gravity. He just said, in general, here's what's going to happen if there's something causing it called matter. In fact, they called it mass is causing gravity. No, it's the volume, as I just explained. Now, let's see what they have to say here. G is the Newtonian constant, and that's what's used for the Schwarzschild radius, the famous relativistic kind of radius of a tiny black hole or something, the Schwarzschild radius of 10-mile black hole or something like that. And they use G, Newton's G. Well, here it is, Albert. This is what causes the big G. It's not just a lump like Isaac told you. It's discovered after 1915 that the proton exists. 1919, the proton was discovered, long after Einstein had promoted his relativity. Now, in 1962, the size of the proton was estimated to be about 0.9 femtometers in radius, like a sphere. So at that point, they knew a volume. Einstein had died in 1955, though, so he didn't really get that kind of information. But you and I, the survivors, are the ones who can use the greater wisdom of the proton size. And by a deeper understanding of reality, we can make an electrical generator. Now, it's simplified the accounting of the Maxwell's equations by going with the 8 dimensions. The photon has no energy, and that changes a lot about the relativity equation. I mean, if they were expecting the general relativity to have some kind of one factor is mass causing gravity, and the other factor is energy causing gravity, and they think these are photons? No. I challenge you. They're not photons. It's matter controlling the energy, and that's making the gravity. You can't have energy without matter. And I'm going to be winding up now on the farewell statement here. So I'll just turn around this wide-angle view here. Oh, over there, there's something there. Iron and manganese. Let's zoom in on that some. Element 26 and 25. Only one proton different, but it's cube 3 on the left and a cube 2 on the right. Non-ferrous. It's the cube 3 that boosted the two rings to be coaxial. Alright, our half hour's over for today. I'm going to sign off really soon.